the day, students. Now let us look into how we get the vibrational or infrared spectrum from a sample and what is the device used for it. So from an infrared spectrophotometer, we are able to get the infrared spectrum or vibrational spectrum of a sample. Now, this is the schematic diagram. We have an infrared source which emits the light, and that light is divided into two by means of two mirrors. The source will be emitting light in all directions. By means of two mirrors, I get to reflect light along two paths. One of the path is made into a reference beam, the other is made into a sample beam. The sample beam will pass through the sample. Now these two beams then again are redirected by means of two mirrors onto a common point where they interfere. And this radiation is studied. Now we need to synchronize this radiation, or we need to have a periodicity in this signal, and hence we make use of a beam chopper here. That is, it may be a grating or a prism that is continuously rotated, and on each rotation, only when this angle becomes 45 degrees will the beam pass through. Hence, this beam is made into a periodic beam pulse. We do this in order to match the sweep rate of the detector. Now, this beam is made into a narrow beam by passing through a narrow slit. This is to reduce the noises. And then that beam is made to fall on a diffraction grating. Now the grating, it diffracts light into its component wavelengths. And each wavelength can be detected by the detector. The detector then amplifies this obtained signal. The detector will be converting this light signal to an electrical signal, and this electrical signal is amplified. And the amplified electrical signal is recorded into the computer or into a recorder. So the different parts of the infrared spectrophotometer is the source, the optical path, the monochromator, the detector, and the sample. First one is the source. Now the source is usually a filament that is maintained at a red or white hot by an electric current. So this filament is made so hot that it glows red or white. Now one of the sources is a Nernst filament. It is a spindle of rare earth oxides of 1 inch long and 0.1 inch diameter. This produces black body radiation in the wave number range of 7,100 centimeter inverse. And its temperature is around 1600 to 1700 degrees centigrade. It is useful to produce shorter wavelengths of infrared region. Now the other source is a Glober filament. It is a rod of carborundum or silicon carbide, and it produces blackbody radiation of wave numbers 5500 to 500 centimeters. And it is maintained at temperature 1200 degrees Celsius. This is useful to produce the source of longer wavelengths of infrared region. The next component is the optical path. Now this source light, it is guided and focused by means of mirrors. The sample is kept at the focus so that nearer to the mirrors, so that all of the beams pass through the sample. And glass mirrors and glass lenses are not preferred because glass strongly absorbs infrared rays. So instead of glass mirrors and lenses, we use uh, holders or mirrors made of mineral salts. Mineral salts are transparent to infrared rays and they are highly polished to reduce scattering. If we are using sodium chloride salt to make the sample holders and mirrors, we can see that it is transparent above 650 centimeter inverse. And potassium bromide is seen to be transparent above 400 centimeter inverse. If we use glass as holders or mirrors, it will absorb these radiations. Now the next component is the monochromator. The monochromator helps to make the beam monochromatic into a single wavelength. It splits the radiation into the component colors, component wavelengths, and each wavelength can be selected. We make use of a rotatable prism or a rotatable grating for making light monochromatic. Now the next component is the detector. There are two types of detectors. The first one measures the radiation by the heating effect, and detects the signal as an electrical signal. The type of heat detectors used are bolometers, Golay cells, thermopiles, and pyroelectric detectors. The next type of detectors are measuring radiation by photoconductivity effect and also detect it as the electrical signal. The type of detectors are lead sulfide or indium antimonide or mercury cadmium telluride. They have to be operated at very low temperatures, at liquid nitrogen temperatures, to reduce the noises in the signal. This has the advantage of faster response time and better sensitivity. Now the detectors will detect it into an electrical signal, and this signal is amplified by the amplifier. Now the next component is the sample, the nature in which we take the samples. First one is the mull technique. Here, a mull of the sample is prepared by grinding it to a fine powder and putting it in the mulling agent like paraffin oil. Now this mull, it is smeared between two thin sheets, two thin cell windows. Cell windows, they are like glass sheets. Here it is not of glass, but it is made of salts, mineral salts. And they are held together, and the mull will spread out as a very thin film. The mull is then placed in the path of the infrared beam. Here, the disadvantage of this technique is that interference will happen due to absorption bands of the mulling agent. Mulling agent will also absorb the infrared beam. So there will be the effects of the absorption due to mulling agent also. Now for best results, what we do is the size of the sample should be less than the wavelength of the source light. The thickness of the mull should be very small, should be less than the wavelength of the source light. Thus, we can reduce the interference effects. Now, the next technique of taking the sample is by the pellet technique. Here, the sample is ground, it is grind into a fine powder with potassium bromide. Then this mixture is pressed into transparent pellets using suitable dies. Pellets are placed in the path of the source light infrared beam. This technique has several advantages. They are the interference bands will be absent, there is low scattering loss, there is a higher resolution of spectra, The samples can be stored for future purposes. There is ease in examination. There is the easiness in examining the sample, and there is better control of concentration of the sample, and also the homogeneity of the sample, the uniformness of distribution in the sample. Now the next technique of taking sample is solid films. Here the sample is made into thin films. A concentrated layer of the solution is allowed to evaporate slowly from the window material. Window material is like a glass plate made of, it is not made of glass, it will be made of mineral salts. So on that thin sheet, a concentrated layer of the solution is allowed to evaporate slowly, and upon evaporation it will form a thin uniform film. Now, by varying the concentration of the solution, I can vary the thickness of the film. Now, the disadvantage of this technique is that thin film produces additional interference effects. Now, this was the different components of the infrared spectrophotometer and the different natures in which we take the samples in it. That's all for today's session. Thank you.